Okay, so one of the skills we need to learn this year is how to use your graphing calculator to help you solve equations and inequalities and things like that. So you need to get familiar with the buttons on the graphing calculator. And the best way we can do that is just to show you. Now you have to be patient with me because I'm trying to set this iPad up so that I can film myself using the calculator. So if I mess up, we'll have to play around with it. But a couple of things. First of all, I want you to be aware, like for example, in example 1, we're gonna solve it geometrically or graphically, whichever way you wanna call it. But if you look at the equation initially, there's only one variable. And when we're using the graphing calculator, the graphing part of the portion of the graphing calculator, we're actually gonna introduce an extra variable that's not there originally to temporarily help us solve this problem. So what we're gonna do is take each of the two sides of the equation and set equal to y. So to delineate the difference between the two, we're gonna call one side y1, oops, and the other side y2, like that. And then we're gonna put that into the graphing calculator. Now, I wrote out all of the instructions. Now, if on a test or an assessment of any kind, we ask you to solve something geometrically or graphically, this is what we mean. And you can use either Calc Intersect or the second example I'm gonna show you is Calc 0. Either one, you can pick either one for this particular method. But what you have to have is to show us what you're putting in the graphing calculator, what the graph looks like, what the important points that we're interested in looks like, and what those points are. And then you have to remember to write the solution, because this is the only way when we're reading an assessment, we know what you actually put in the calculator. We can't sit next to every person and watch this, so therefore you have to show us what it looked like in the calculator. So it is really, really important that on an assessment, if this is asked, you have to write this. This is why I wrote there. You must write this out by yourself every time you solve geometrically. Each time you're gonna show me what you're putting in the graphing calculator. So let's actually do that. Let's put this in the graphing calculator. So, let's hope I do this right. Insert camera. Oh no, I don't do it. Let's see. Maybe I'll do it this way instead. Camera. I'm hoping this works. I hope this records. Let's turn it on. Okay, the on button is down here. I don't need to show this again, but for us to enter these two functions into the calculator, these two sides of the equation into the calculator, I need to go to y is equal to. It's right under the screen to the left, y is equal to. Now, a couple things I want you to pay attention. First of all, you may have something written here already. If you have a brand new calculator, that's not the case, but if you got the calculator for someone else or you've used it for something else, make sure you clear it out. I would actually use the arrow down key and just make sure that none of the other parts are filled in, like all the way down to the 10th one or the 0. And also up here where it says plot 1, 2, or 3, just make sure if they're highlighted, it means that they're turned on. So I'll show you what that looks like. Like this, I hit enter. That means right now, if it's highlighted as it is now, it's turned on. The calculator is trying to do two things at once. So it's really important that you go up there again, using the arrow key, highlight, hit enter, and it deactivates it like that. Now, the next part is to put in my left and my right side of the equation. Now, of course, I don't remember what that was, so let me just see here. Whoops. There. It's absolute value of x minus 3 and 5. So let's go back to where we were here. So to put in the absolute value, the place that happens in the graphing calculator is in this button, it's math. And up here, you have several menus up at the top. The first one, choice number 1, is finding a fraction, converting something to decimal, some roots. We need to go into the numeric menu. So we're going to use the arrow key to move to the numeric menu. And the first choice is absolute value, ABS. So we're going to hit enter. And I'm going to put in the x minus 3. That's the inside. You see the absolute value bars? Now, with an older calculator, it may just say ABS with a parenthesis. That's okay. Just make sure you put in x minus 3 here. x minus 3. And then end the parenthesis if it says ABS, and it doesn't. This one is a newer one, so it gives me the absolute value bars. So that's my y1. That's the left side of my equation. And then I'm going to put in my right side. It happens to just be 5. Now, it could be anything. It doesn't really matter. But what we're looking for is where y1 is equal to y2, or the y values of each of these graphs are the same. So y1 is going to graph the absolute value of x minus 3, which should look like a V shape. And this is going to be a horizontal. y2 is a horizontal line at 5. And we're looking for where they have the same y values. So a couple of things. First of all, I can go and just hit graph. Now, if I just hit graph right now, it'll give me like whatever window was used last. A lot of people use negative 10 to 10, negative 10 to 10, but if something else has been going on and it's been used for something else, it may have like a funny window that doesn't show the graph. So instead, I tend to always go into Zoom, and then choice 5 is Zoom standard. The Zoom standard window always goes from negative 10 to 10, negative 10 to 10. It's a good start over button. So I'm going to either use the arrow down key to get to 6, or you can just hit the number 6. I'm going to hit the number 6 here, and then it'll graph it. There is my absolute value, and there is my graph. Now, or my y1 is equal to, or y2 is equal to 5. What I'm looking for is where the y values are the same. The y values are the same where the graphs intersect. So I'm interested in this point here and this point over here. So we're interested in where these two things intersect. Now, on the graphing calculator, I am going to go in, and I can see here, by the way, that both of the two intersections are showing. If one of them was not showing, I would have to have both in the window for the graphing calculator to be able to find them. I would then have to go into window, and I could change the window to suit whatever size graph I needed. So in this case, okay, I'm happy with where it is because both of the intersections are showing. And I can see if it was cut off like this, I could see, oh wait, they are definitely going to intersect somewhere. I need to somewhere else. I'm definitely going to have to make the window bigger to be able to see it, and I could expand it if I had to. But in this case, it works, so that's great. One of the hiccups that the graphing calculator has is like, yeah, it can calculate the intersection for you, but it can only do one at a time. So I'm going to show you how to find the first intersection, and then we'll talk about how to find the second one. So in this particular case, I'm above the trace button. Do you see how in blue it says C-A-L-C? That means calculate stuff related to the graph. So that's what we're going to ask it to do. So the blue button, or the second button, and then trace, because it says in blue calc, that tells me use the blue button, hit the calc button, and we're trying to calculate the intersection. That's choice 5. So I can either hit the 5 button, or I can hit the arrow down key and enter when I get to 5. I tend to just hit 5. So now I'm back to the graphing screen. And what I want you to notice up here in the left-hand corner, it's asking you or telling you what graph the cursor is sitting on. It's on y1, your absolute value function. And it's asking you, which one do you want? Do you want the first curve to be? I want it to be y1. Now, the reason why it's asking you this is that you could have 10 different functions written, and and graph for that matter. And if you wanted just to find the intersection of two particular functions, I would have to then arrow up and down to pick the functions that I want. Like, look, if I use the arrow key, do you see it goes to the next function that I have stuff for? Now, we only have 2 things in there. So that means that when I hit the arrow down or up key, I am back at y1. So for us, we want the intersection of y1. So I'm going to hit enter. And then it picks what is the second curve. I want it to be y2. If I didn't want it to be y2, I would use the arrow up and down key. In our case, we only have 2 functions, so it's gonna be y2. So hit enter again. For some reason, the TI-84s have this guess feature. I don't wanna guess. It doesn't matter to me. I just want the calculator to find it. So I'm gonna skip over guess by hitting enter. And it'll tell me where the intersection is. It was at -2, 5. But the problem is it's only finding one, and I need to find the other one. So the way for me to find the other one is to do Calc Intersect again. So Calc Intersect, choice number 5. But before I choose my functions, I am now going to use the arrow key, and right now, I'm physically closest, the cursor, it's like a little spider sitting on there, is closest to the left intersection. For me to find the other one, before I choose my functions, I'm gonna move it over to be closer to the right intersection. So look, I'm gonna be absolutely positive I'm closer to the right. And now I'm gonna select curve 1, curve 2, enter, and I don't wanna guess. And there it found the second intersection, which is at 8, 5 in this particular case. So now I've found all of the pieces that I need. Part of doing it geometrically on a test, you'll have to then draw the picture, or tell us or sketch the picture. It doesn't have to be exact, but like close to it. Sketch the picture, give us the points of interest, which is where the two intersect. Give us the X and the Y axis with the X and the Y scale on it, because if you had to change the window, we would need to know that. And the solution. So let me show you how to do that on here. So currently, we've written down what we put in the graphing calculator. Now I have to then put in what the graphing calculator did. So if we think back, the picture of this had an X and a Y axis here, and I hope you followed along on your graphing calculator. Oh, look, I'm not the most precise picture here, but the window that we used was from -10 to 10, -10 to 10 for the X and the Y axis. I'm going to show that. I'm also going to show that it looked sort of like this. Is it going to be a 100% accurate? No, but close enough. The key is make sure the intersections happen in the right quadrants, like that. Do you see how I'm not putting the hash marks or anything like that? I put the scale in, I put a reasonable spots where they'll intersect. I put a reasonable, like my horizontal lines are not the greatest, and the same with the absolute value. But I found these 2 points, which was at -2, 5. I'm gonna put those in, and 8, 5, that's the other point that I found. So now I have the scale on there, I have the graph on there, I have the X and the Y axis and my points of interest. Now I just have to give the solution for it. And in this case, the solutions are where the two Y values are the same. But I'm not interested in Y, I introduced Y. So I just have to remember what we're actually solving for is X. So in this case, the solution would be X such that X is equal to -2 and +8. Now, this is a simple enough problem that we could do it conceptually. So if you look back at the problem itself, it actually means all the values that are 5 away from 3, and 5 away from 3 is -2 and +8. So, oh, look, geometrically, I'm finding on the graphing calculator the correct answer. It's just a different way. Now, I picked a simple problem so that you can see, okay, I get the same answer regardless of which method I'm choosing to use. So in this case, it's the graphing calculator. Now you can use this method to solve basically any equation using a graphing in the same way. Let y1 be the left side of the equation, y2 be the right side, calc intersect. Even if it's functions you're not super familiar with, this will still work. You just have to make sure that whatever intersection you're looking for is showing in the window, and then it'll help you find that. So that's calc intersect. Now, there is another option. I could also do something called calc 0. So that we're going to do that in